Okay, so hello everyone, and welcome to the week 8 tutorial session. And in this week, we're going to cover actually the topic of wait a second, the topic of the plane kinetics of the rigid body. And in that case, we're going to have both the impulse and the momentum at the same time. That's coming from the chapter 18 from the textbook, Principles of the Impulse and Momentum, away from the number of the question you're going to see is starting from 19, but actually it's from chapter 18. So we just continue what we done earlier, but in that case we are going to add both the angular and the rotational um, momentum in the calculation we're going to have. So we start with the first example, which is going to be about a 10 kilogram cylinder rolls without slipping at the point A. Determine what will be the angular velocity after 4 seconds from the starting of this, or after starting from the rest. So now we know that the time is going to be 4 seconds, 0 to 4 seconds. Starting from the rest, that's mean the omega 1 is 0, and we know that the mass is 10 kilogram given to us. We can find the Ig for this case in very easy way because we know the radius and we know the mass. Anyway, maybe it's not clear here, but this is 5 Newton meter is given to us as a torque. And maybe this one is going to be more clear for the free body diagram. 5 Newton meter to the clockwise direction. The weight is going downward, located at the point G. The radius is 0.2 meters. We have here a friction force, and we have a normal force on the system. Again, we can simply sketch that as a kinetic diagram and a free body diagram, as we're going to see in the next page. So we need to define first that the cylinder has general plane motion, roll without slipping. And the free body diagram will look like this one. The weight going down, the friction force and the normal force, and also we have the torque going in that direction. In the kinetic diagram, we are going to have the Ig omega 2. We are going to have the mass multiplied by the velocity 2, the velocity of the center 2, because the velocity 1 was 0. That's the point A. We said that we don't have any slipping here, so that means that the velocity 2 is going to be equal to the omega from here to here, multiplied by the, let me use a pen here. So it's going to be, the length of the rotation is going to be this one. It has the R value, which is Rg/A. Okay, and of course this will be equal to 0.2 and multiplied by the omega we have here, which is going to be the omega 2, which we don't know how much at this moment. So the known are going to be first the mass, second the moment, third the time 1, fourth the velocity g1, fifth the omega 1, and finally the time 2, which is 4 seconds. So what we need to know is the omega 2, and then from there, of course, we can find the velocity 2, because the velocity 2 is going to be equal to the omega 2 multiplied by the r. Now we know that the velocity in the vertical direction is equal to 0 because mainly the velocity 2, or the velocity at the center, is going to be related to the omega, and in that case the omega is perpendicular on the vertical r value of the GA, and thus only going to have an x-axis value, which we don't know how much. We're going to assume for the calculation that the omega, though is going to be to the clockwise direction, is going to be a positive value. And we're going to do the calculation. So in today's tutorial, we're going to have a set of equations we're always going to use for the rest of the tutorial questions. We have the linear momentum, which is going to be equal to the equation of the mass multiplied by the velocity in the x direction, plus the sigma of the integration for the force as a function of the time is going to be equal to the mass multiplied by the velocity g. The y direction, the same thing, okay, but the force is going to be to the y direction, and the time 1 to 2. For the angular momentum, we're going to have the h g1 plus the sigma of the integration for the moments at the point G to the dt equal to hg2. Or we can have it around the point A, which is going to be it's either going to be around the point G or around the point A. And in that case, we're going to have the HA1 plus the sigma of the integration from the moment around the point A to the function of time is going to be equal to the HA2. So we don't have to use both of them. You can use only one of them and it's going to give me the answer. So we start now with the solution, but before that, let's explain what do we have in this equation. So the mass multiplied by the velocity is going to be the initial linear momentum when we are going to have the velocity 1. The linear impulses is going to be the integration for the force as a function of time. That will be the linear impulses. And then the second side, the second part of the equation is going to be the final linear momentum. So that's the initial linear momentum here. And this is the final linear momentum, and the linear impulse is going to be in the middle. While we have in the angular momentum equation, the first one is the initial angular momentum. This is the angular impulses. And of course, we're going to have the final angular momentum on the other side of the equation. What we're going to do is we're going to explain to you how we are going to expand this equation to find the H1 and the H2, and what the parameter we're going to use for that, and also the moment, the angular momentum we're going to have for these equations. So we start first by calculating the IG for the circular shape. So simply is going to be equal to the half of the mass multiplied by the radius square. You remember that the mass was 10 kilogram, the radius was 0.2, so we can have the answer to be 0.2 kilogram meter square. Now we're going to use the equation C, which was about the angular impulse. So we're going to have the equation to be that the hg1, and that will be the first moment we're going to have around the point G. That's the second moment around the point G, and that will be the hg2. So hg1, hg2, and the first moment we're going to calculate, which is going to be, of course, the momentum that we've been given to us, or the torque, and this will be equal to the friction force multiplied by the radius. Now just remember the shape was like that. We have the friction force here, whatever the direction is going to be, and it's going to be something like r distant to the g. So of course, multiplying this force by this radius will give me a moment in that direction. Both going to have positive value because we're concerned that the clockwise direction is going to be positive value. Now, for this part, it's going to be 0, of course. And for this part, it's going to be 0.2 omega 2. The torque given to us as 5, 0 time here, 4 seconds here. So it's going to be 5 times 4. For this part, it's going to be the FA multiplied by 0.2 multiplied by 4. And thus we are going to have the function of the equation of the omega 2 in one side and the FA on the other side. And this will be my equation 1. Now we're going to go to the linear side. And in that case, we're going to have the mass multiplied by the velocity in the x direction. Okay, and we're going to have the force change, or the friction force, or the horizontal force change as a function of time, and it's going to be equal to the mass multiplied by the velocity and the x direction after 4 seconds. So we don't know what the velocity is, but we can write it down as a function of omega because it's rolling without slipping. So the velocity is going to be equal to the r multiplied by the omega, or 0.2 omega. So now I can substitute all these parameters in the equation here. We know that the velocity horizontal one is 0. And this one now is going to be written as 0.2 omega. The FA is unknown, but the time is 4 seconds. So I can write down the equation to be 0 plus FA multiplied by 4 seconds. And it's going to be equal to negative 10 multiplied by 0.2 omega 2. Okay, so we got that, and we're almost there. Now, my question is why we got the mass multiplied by the velocity x2 is equal to 0, equal to negative value, because this one is going to the left. Okay, this force is going to the, going to the right, while this one we consider it to be positive because it's going to the left. So that's why we're going to keep this sign, and it's going to help me later to do the solution. Now we have two equations, both having the FA and the omega 2. So I can say from the second equation that the FA is equal to 2, which is 0.2 multiplied by 10 is 2, divided by 4. So this will make it 0.5 omega 2 negative, of course. And then we can substitute in the first equation, and we will get the value for the omega 2 to be equal to negative 33.3 radian per second. Okay, so that's it. We found the answer for the omega. Now, what will be the case if we're going to use the equation C bar, which was about the moments around the point A? So that will be the equation we're going to use. You can see that the H now is going to be changed to be Ig omega 1 plus the mass multiplied by the Vg2 multiplied by the R. That's for the H, A1. And the change for the time from 1 to 2, and the moment, of course, going to be the torque, of course, going to be used here. And then on the other side, we're going to have the same equation, but it's going to be with the omega 2. Now we can tell that the first part for 1 is going to be 0 because both the velocity and the omega is equal to 0. So here we're going to have 5 multiplied by 4. And on the other side, we're going to have 0.2 multiplied by the omega 2, 10 multiplied by omega 2, 0.2 omega 2 multiplied by 0.2. Okay, so you put everything in, and then we will come to the answer. That's it. We have the omega 2 on one side and the torque multiplied by the moment on the other side, torque multiplied by time on the other side. Then we come to the answer that the value of the omega 2 will be equal to negative 33.3 radian per second. That's it. Well, it's quite simple, but it's need to have what do you call it, more patient with analysis of the question. We're going to have another equation. We're going to solve it the same way, and this will be follow this question, this